What are the transformations you guys know of so far? Reflections, yep, that's today and tomorrow for us. Rotations, we will talk 3 days of rotations in here, yep. Dilation, yep, and translation when I slide a figure around. Yep, those are the 4 you're familiar with. Those are the 4 we're going to talk about, but probably go in a little bit more depth than what you're used to. And on Wednesday, make sure you got a compass and a straight edge. Wednesday, Friday this week, we're going to learn how to do constructions with all these transformations, all right? So transformations, you're taking points on a graph and moving it somewhere else. We can all agree with that? Take a set of points and move it somewhere else, whether that be by rotating them, sliding them, reflecting them, whatever, all right? Now, if what I end up with, I didn't change the segment length or the angle measure. Anybody remember back from Unit 4, what do I call those types of transformations where the segment length is still the same and the angle measure is still the same? Those are called rigid motions, yes. And there's our first blank right now. All right, preserve length and angle measure are called rigid motions. That's a term we're going to use a ton this unit, rigid motions. You guys name 4 for me. How many of those 4 would be considered a rigid motion then? Translation, yep, that won't change anything. Rotation doesn't change anything. Reflection does not. The only one that would was dilation, which would change segment length, but not angle measure. So dilation preserves angle measures. All right. And a quick vocabulary update here. The figure you start out with. So you're going to take this figure and you're going to slide it. You're going to rotate it. You're going to reflect it. The original figure we start out with, we're going to start calling the pre-image. Good job. Didn't know if anybody knew that. Guess not. Pre-image. And then after I'm done transforming it, what I'm left over with, we're going to call close. That's pretty good. Just the image. Just the image. All right. Okay, real quick on rigid motions here. Take a look at my 2 triangles. I did something to the first one to the left. I don't know what I did, all right, but I transformed it. With what I did, is that a rigid motion? Is that a rigid motion, what I did? What's a rigid motion again? It's got to preserve 2 things. Side length and angle measure. What does it not preserve here? Okay, so this would not, whatever I did is not a rigid motion. So no, because side length is not preserved. Good, good. Probably the most amount of writing you guys have to do today. Preserved, good. What is that at the end? Okay, I can't. Not any better. What about 2? I did something to this one on the left and got the one on the right. I don't know. I transformed it somehow. Did I preserve side length and angle measure? Looks like it. Yep. So this would, whatever I did is a rigid motion because side length and angle measure look preserved. Okay. So everyone all right with this concept, rigid motion? We won't talk about it for the rest of today, but it'll come back up in the next couple days. All right, I want my focus today, tomorrow, and Wednesday is all going to be on reflections. Okay, all going to be on reflections. Today is basic reflections. Tomorrow is honors reflections, and then Wednesday will be let's take your darn compass and straight edge and how do I reflect it using arc marks. All right, notation. I don't know if you ever knew that there is a symbol for reflection. It is a lowercase r. Lowercase r. Well, why isn't it an uppercase r? That's reserved for something down the road we'll talk about. All right. And then not only will you see a lowercase r, you will also see a subscript. Anybody know what I mean by subscript? A little something down below, right? And down below, what you guys will see is the line we're going to reflect over. Whatever line we're going to reflect over, that'll be the subscript. So I'm just going to write line of reflection here. Okay. So that's what you'll see in the subscript. So for example, you could see this. R, reflection, subscript, y-axis. What's that tell us? We're about to, one, what's that R, little lowercase r? We're about to reflect over the y-axis. That's what that means. Okay? All good? Ready to do some basic ones you probably did in middle school? All right, so my first starting point is going to be 2, -1. All right, so we can all take our graph right now. Go ahead, graph 2, -1. And I'm going to call it point A. Okay, 2, -1. We're going to do a lot to 2, -1. First thing we're going to do, symbol notation tells me to do what to the point? Lowercase r tells me we're going to reflect it where? Through the x-axis. Okay, let's go backwards here. Is distance preserved in a reflection? Is distance preserved in a reflection? Yes, it is. So now I ask that because what is the number of units A is from the x-axis, the line I'm reflecting over? How many units? 1, which means it's going to stay 1 when I go and reflect it. So it's 1 unit away. So I go another unit on the other side, and I end up with this point right here. Now, I don't want to call that point A anymore because I already know A is 2, -1. You remember how I rename it now? A prime with that little symbol there. A prime. And what is A prime now? Actually, name the coordinate for me. A prime. That point is 2, 1, correct. 2, 1. Stuff you've done before, correct? Okay, let me take it next level. With A and A prime, can you connect those for me, please, on your graph with a line segment? Please connect those for me. Okay, everyone see the segment that's created, A prime. What line did we reflect over again? X-axis. Look at the x-axis right now. Take a wild guess. You don't need to guess. You know for a fact. What's it doing to segment A prime, the x-axis? Oh, it's bisecting it. Go deeper. And it's perpendicular. So the x-axis, put the two together, is a what? Perpendicular bisector. That's a point I got to drive home to you guys today, is the line you reflect over is acting as a, what's the x-axis here? Perpendicular bisector for the segment when you connect them. All right, let's go on to the next one. Now I'm going to reflect over the y-axis. Still 2, -1. Still 2, -1. All right, let me talk to somebody here. 1, here we go. How many units away is A from the y-axis? 2, so distance stays preserved. Go 2 units away. I can still call this A prime because I'm doing it on the original. If I did it to A prime, we'd have to call it something different. But all right, what's my new A prime? Here you go, 9. What's my new A prime? There you go, -2, -1. Don't do it on your paper. Watch me do it on mine. I connect them. What line did I just reflect over? See what the y-axis is doing? It is a perpendicular bisector every time. Okay, the line of reflection is the perpendicular bisector. All right, now we're going to get a little nuts. Hopefully I don't lose you. Now, what line do I want to reflect over? y equals x. Ooh, I can't. Ooh, what's that line look like? Anybody know what that line looks like? You want to air draw it? You can. Going right through the origin with the slope of 1. Ooh, okay. How are you going to reflect A over that one now? I can't be, well, if I put my finger here, it's about that long, so I'll go on that side and maybe I'll get it. I don't think so. Okay. I'm not going to show you how to do it on the graph. I'm going to just have you remember the rule. If you ever reflect over the line y equals x, we do this to the coordinates. Anybody want to guess what we do? No, it's just we're not doing anything on the graph. I just want you to remember the rule for this one. What's the line we're reflecting over again? Y equals your x. And then if you go backwards and read it, it says your x is equal to your y. Anybody know what we're just basically doing to the coordinates? If your y now is equal to your old x and your x is equal to your old y, we're just flipping them. That's it. When you reflect over this line, we're just flipping the coordinates. So what does A prime look like? What coordinate would A prime be? Oh, 11, yeah. Ones, let's go. What is it? -2, 1. Did we say change the signs? I don't think I did. We can go back on the tape if we need to as well. What did we... Okay, what's flip the coordinates mean to you? Flip the x and the y. Don't change anything. Ready? Flip. Ready? Flip. What do you got? We all good? Naomi, just a little forearm shiver right there. Wake them up, please. All right. Thug life needs one there. All right. Again, Delmar. Southside Delmar got a rep with the hood. All right. Everyone good? Flip the coordinates. All set? All right. Next one. This one drives me insane and will for the entire unit. What type of line is y equals a number versus what type of line is x equals a number? Y equals 2. Do not say a straight line because they're all straight. What type of line? Yes, that is a horizontal line. Y equals is always a horizontal line. Again, distance still preserved. How many units away is y equals 2 from point A? Count them for me. Here you go, 3. How many units away? 3. You go 3 in the other direction. 1, 2, 3. Here's A prime, which will be what coordinate for us? Oh, 20. 2, 5. So look, hey, everything can be done on the graph. I'm asking you to remember one rule. Actually, 2. Another one's coming up, but one rule right now. Everything else can be done on the graph. We good with the basics? All right, another one here. Take 0, 5. Where's 0, 5, by the way, before I lose it? 0, 5. X or Y axis? 0, 5 is on the Y axis. Hi, I'm 0, 5 right here. Reflect it through x equals 2. What type of line you're going to reflect it over then? X equals 2. 23. A vertical line going through 2 right there. There it is. Distance stays the same. Bless you. 24. How many units away is x from x equals 2? 2 units. Go 2 units in the other direction. Here's x prime. Name it. Name it. 1 x prime. 4, 5. Okay, we all good? Before we get to this next part. All right. I know I shouldn't have to say this every unit, but this unit in particular, you have to read carefully. Because in part B, which point am I asking you to reflect? X prime, not X. Don't go back to 0, 5. Stay right there at 4, 5 and reflect it through the line y equals -3. What type of line? Y equals -3. 14? What type of line? Horizontal. And I love this one because some of you guys, 1, 2, 3, 4, 5, 6, 7, 8. I go 8 in the other direction. 1, 2, 3. Oh, the graph ran out. What do I do? Oh, use your math ability, maybe. Okay, use it. You're not going to be able to count. And then if I see any of this, I'm just going to extend the old graph. Yep, that's the old good one, so I can count. No, get out of here. All right, get out of honors. All right. And I'm sorry if I'm just blowing up some of your spots. Sorry. Sorry. What point do I end up with? 5? There you go. Yes, there you go. 4, -11. Think about it, right? You had to go 8 units. If you have to go another 8 units down from -3, -3 minus 8, -11. What do I want to call that point? X double prime, because I reflected the single prime one. Yes. Congratulations. Way to go. Any questions there? One more. Well, it just was. Okay, let's get moving here to make up for some time. FG. I put it into symbol notation now. What line are we going to reflect F and G over? Y equals X. This is something, again, one of the only rules I've had you remember so far. Y equals X. What am I going to ask you to do to the coordinates? Y equals X. Y is equal to X. Here you go, 6. What am I asking you to do with the coordinates? Flip them. Go ahead, Mike. F prime, 0, 3, and G prime, 3, 4. There you go. And read directions. It doesn't say, it just says to graph the original, so that's all I'm going to graph just to save some time. All right, next one we got to work together. Reflect FG over this new line, y equals -X. All right, just a little visual what I'm doing here. Here's y equals -X. Maybe. There it is. Going through the origin, but now with a negative slope of 1. What do you think now? Well, what do we do with y equals X? We're going to flip them. So we'll still flip them, but now change the sign. All right, so now we'll still flip, but now change the sign. So I'll say flip and negate the coordinates. And again, reading. Which coordinates are we going to do this to? FG, the original ones. All right, don't go back to the old ones. It says reflect FG, so we could still call this F prime and G prime, since we're going back to the originals. Okay, so flip and negate. What do we end up with here? 12. What about F prime? 0, -3. And then, how about G prime? Yep, I would have just kept that to myself. But questions? All right, last thing in this part. I've told you guys what line to reflect over. Now you find that line. I'll give you the pre-image and the image. What line did we reflect over? Okay, so go ahead and graph ABC, A prime, B prime, C prime. So if you're given the pre-image and the image, what line did I reflect over? All right, so you see those two? What line's going to be the perpendicular bisector for AA prime, BB prime, and CC prime? And let's get used to writing in our notation, reflection over. When you have it, let me know. Take your time. 17. What line are we going to reflect over? Who's 17? And when you're ready, let me know the line you're going to reflect over. Is it going to be vertical, horizontal? It's going to be vertical. Yep. So that already tells me it's got to start out with what if it's a vertical line? It starts out with Y. No, I don't know. X. Which one are we going with? X. X. Good. X. There you go. X equals 3. Any vertical line? X equals. Good. All right, everyone all right with line reflection? Because now if you can reflect through a line, you can also reflect. Oh, that's not even there yet. Never mind. I'll save that to this problem's done. I wanted to just throw in a quick regions problem using reflections. Everyone love the rhombus you got there? What transformation could I do that carries it onto itself? Just a quick little vocab here, onto itself, meaning which one of these four could I do? And you get that same rhombus back, same coordinates. So the coordinates don't go, well, they go somewhere, but at the end, you're still left with this rhombus. Okay, so that's what onto itself means, is you get the exact same thing you started with. All right, let's go through number 1 first. I know we have not gotten to rotations yet, but 180-degree rotation. Everybody right now, 2 hands on your packet. Where is first of all, before I do anything, where is counterclockwise, to the left or to the right? Think of a clock, to the left or to the right. Okay, so everyone ready? 1/4 turn to the left of your packet, go. That's how many degrees? 90. One more quarter turn. So basically upside down. Look at that rhombus right now. The original one's still up on the board. Is that the same one we started with? Is that point still the same? No. Is that point still the same? No. So is this the original rhombus? No. Go back to the original. All right, so that's out. Can you guys just look at it now? Can you find the line you reflected over? That takes one point, keeps it, matches up to another, or keeps it the same, but you still are ending up with the same rhombus. Don't use any of these. Just tell me in your own words, what line do I reflect over? What line do I reflect over here where this rhombus stays exactly where it is? Okay? Just name the line. Don't give me an answer. 24, just name the line. The y-axis. Everyone agree? Here we go. Where's that point going when I reflected over the y-axis? Nowhere. It's on there. Where's this one going? Over here. And where's this one going? Over there. Where's this one? Nowhere. Does everyone see I'm left with the same rhombus? So y-axis, but that's not a choice. Y-axis, what type of line is it? Vertical. We've said all day today, vertical lines always start out with x equals, and in this case, it goes through 0. There it is, x equals 0. All right. Now what I wanted to get to a couple minutes ago, if you can reflect through a line, you certainly can now reflect through a point. Go ahead, graph art up. And make sure you graph the point of reflection for 1. Genie. All right, this is still a reflection. What do you know about distance? Still stays the same. All right. Now, I know this is easy. We'll just say, oh, hey, look, there's 2 units from point A, so I'll go 2 units in the other direction. And we could do the same thing with R. But what class are we in? All right, I want to start with point T. Don't do A and R. Of course I do. You're darn right. I want to go through point T. Because I know, look, from point A, 1, 2, 1, 2, I got it. And I can do the same thing with R. But I want to start with point T first. Because you may go to homework tonight and all the points look like point T, where you just simply can't count over. All right, so how do I accomplish this? All right, so ready? Somebody, I'm going to ask somebody right now, give me directions on how to get from point T to my point of reflection. Up, down, left, right. That's what I'm looking for you. Give me directions. If I start at point T, how do I get to my point of reflection? Give me directions. 4. From point T, where do I go? Down 2, left 4. Everyone agree? Distance does what with reflection? Stays the same. Ready? Down 2. And what was the other one, Jacob? 1, 2, 3, 4. There it is. All right, and some of you guys started chirping up with it when I asked at the beginning, but yes, when you reflect through the point, you're going to use slopes. Okay, use slopes. So I went down 2, left 4, do it again. Do it again. There's point T, or T prime. And then go ahead now, you can fill in A and R prime. Down 2, stays the same. Left, 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. There it is, R prime. So easy adjustment there. Find the coordinates, all right? So I'm just going to have somebody, what was A prime, R prime, T prime for me. My copy. Everyone have a nice weekend, balled up in the corner of your room. Probably was a little warmer than usual in there, huh? Anybody do anything good this weekend? Good to hear. Even if they told me, Jacob, I wouldn't care, right? Nothing exciting from period 2? So right up in there. Just right there, curled up. 12, what do you got? A prime. R prime. You're 2 for 2, don't screw it up. T prime. There you go. Thank you. Final thing we got to do, find that point of reflection now. I know what the pre-image and the image look like. Swing. Swing right there. Okay. Okay, so go ahead, graph ABC and A prime, B prime, C prime. Pre-image and image. Where's my point of reflection? And again, I get it. Oh, just go halfway in between A and A prime or B and B prime. I get it, but we're not doing that. Guess where we're going from? C and C prime. Yep. How to find the point of reflection if all the points look like C and C prime. So we're going to go C to C prime here. It's a point reflection, so you guys know we're using slopes. Give me directions. Starting from C to C prime, how do I get there? That's what I want to know right now. Going from C to C prime, tell me how to get to C prime if you're going to start at C. Give me those directions right now. 18. How do I get from C to C prime? Down 4 and left 8. What do you think I'm going to do with these directions to find the point of reflection? Cut it in half, right? So instead of going down 4, I'll go what? Down 2. And instead of going left 8, I'll go left 4. There you go. Here you go. And watch where we end up. Probably the same spot you would find from AA prime. Ready? Down 2, left. 1, 2, 3. There it is. Okay. And yeah, it's halfway in between A and A prime and B prime. What is that point of reflection? And I still got one more honors level question for you, so don't pack up once I find it. Point of reflection? 2? What is that point? 1, 2. Before we end the day, you ready? Deep breath here for this question. 1, 2 was our point of reflection. Those were the coordinates of C, C prime. How does 1, 2 relate? C was 5, 4. C prime was negative 3, 0. How do I get a 1, 2 out of there? 1, 2. No, just stop talking. Or breathing, for that matter. Help us all. Whoa, too harsh on that one. Oh, got a couple O's out of that. All right. Sorry. We're into March now. Come on. We're in the March. 1, 2. It's the what of C, C prime? Midpoint. It's the midpoint. If you add your x's and divide by 2, add your y. So algebraically, if you don't want to do it on a graph, you can just say it's the midpoint of any image and pre-image. So it's the midpoint of C, C prime. Okay, point of reflection will always be the midpoint between an image and its pre-image. Okay? All right, nice job. Graph means what? It's a graph tonight. If you need a couple slices, come up and get them, or not, use the back of your packet.